Okay, so we will be talking about AI in exploration, not only opportunities, but we will also see some risk of this approach, and we will conclude discussing not only as AI can be useful to us, but also how we can be useful to artificial intelligence. A good starting point for talking about AI in exploration is probably what we have seen a couple of weeks ago about the NASA Perseverance mission. I mean, looking at the press release from NASA, I could see, a massive use of AI. AI is almost everywhere, starting from let's say the landing, images being taken, have been analyzed, have been understood, decisions have been taken during landing on board to choose the best spot for landing. Not only because a trained eye in artificial intelligence can recognize also, not explicitly acknowledge the use of AI in here and there, you know, when they talk about improved autonomous navigation, when they talk about AI for targeting instruments, AI-powered payloads, so it was almost everywhere. As we said, this is the second talk about AI. There was a very interesting question raised on the first talk. What is actually AI? Why this question? Because to understand why AI can be not only an enhancer for operations, for space exploration, but actually a game changer, we need to understand some things. The question was very well posed. I mean, what is AI? There is an attempt at saying, like, for instance, I'm using neural networks, I'm doing AI, I'm doing machine learning. Yes, you're doing AI, but not only. I mean, we say that AI is more than that. Or maybe as an attempt of defining AI in terms of intelligent application. I mean, you're using AI when the application looks intelligent somehow, right? But this is also tricky. This is, intelligence is a moving target. What was perceived as intelligence 10 or 15 years ago, maybe today is not anymore. We think to Google, for instance, that is using AI when it's kind of profiling us. He understands that we like Asian food, for instance, so when we look for a restaurant, he's prioritizing Asian restaurants. He's doing AI, but we don't see it anymore. Another point is related with, systems that shows some types of autonomy. So we're doing AI again, yes and not only because AI is definitely an enabling factor for autonomy, but it's not the only one, because we need to ask ourselves autonomy with respect to what? In industrial robotics, we have amazing machines that can build entirely a car without any human intervention, but they don't use it. They can do that without using any AI. Why on the other side, when we have the cool robot in Star Wars that cannot even speak, but can be perceived as much more than an AI. So it's probably worth to spend 1 minute to understand one concept, actually. I mean, the big picture of AI. At the end, computer science, everything boils down into having data and transforming through computation into other data, algorithms or procedures or whatever. But you're doing AI when you have an additional level on top based on knowledge. That means that you don't only transform data into data, but you transform data into information, doing some inference on the knowledge. It doesn't matter how you actually provide this knowledge. Can be a model, like in model-based AI, can be learned from data, or can be, trained using simulators or the real world. But what is distinguishing factors that you have some knowledge? So at this point, you can afford some tasks, like think to recognize a number in a picture, for instance, and extract not only the data that this is the number 2, but only the information. You can do that with various formats. For instance, if you have a number represented like 7 segments format, you can do the same, but you're not doing really AI, because you are morphing data into data, not using knowledge. Last but not least, what makes really AI a very, game changer is the fact that you can use a mechanism of inference for deducing new knowledge. So you can use the same system that you have used for recognizing a number in a picture to recognize much more, complicated stuff. And then we can say that you are actually doing, and we'll see which is as advantages, but it has also can be also a risk for various things. So basically doing AI, you implement a sort of loop that goes from the data, learning, modeling the knowledge, and reasoning about this knowledge, doing inference of deduction, then generate interaction. Okay, in robotics, this is pretty evident, but this loop is somehow present in all the AI applications. So to ask yourself if we are doing AI or not, you can somehow recognize this loop, and you must be able to reason at a knowledgeable level. Coming to us, to space exploration, why do we need AI in exploration? Well, we have a very distinguishing factor in our field, in space exploration. This is the time delay. You cannot go around that. I mean, this is there. I mean, on Mars, you have, I don't know, 20 minutes round trip time for the signal, not only physical limitation, but also technological limitation. But if you think more in perspective, I don't know, Alpha Centauri is something like 4.5 light years away. So basic physics tell us that we will have at least 9 years round trip time. You cannot really think to send something there without some sort of knowledge management. Besides that, there is the issue of unknown and hazardous environment. We have some jokes here that, okay, they are fine, of course, but they make a point. There is a joke in these points. Because during exploration, you must be able not only to see, but to understand somehow what you are looking at. This is not only visual, it's any type of sense of information, but the point is that you have to raise up from the level of data management to the level of information management. You can't foresee really all the possible tasks that you will be asked to once you are there. So this, you need flexibility and capability of reasoning for doing opportunistic science, for instance, as well as intelligent assistance. We'll come back to that later. So how this is supporting our agenda, because I mean, our goal in the long term is to expand the human presence into the solar system and beyond. You know, and not only, but also enable sustained living and working around the moon and Mars. At the end, to understand our place in the universe, to place us there, and maybe also look for life behind our planet. We are devising an increasing complex roadmap that starts from activities in LEO. Then we are talking about robotics missions. Then we are, going into the business of the space gateway in lunar vicinity, for instance, to establish a platform for learn and start to work more in long-term living in deep space. Then we go on the lunar surface, not only boots on the ground, but colonization, that, as we will see, it has a strong implication on the technologies that you need in perspective to go to Mars and beyond. Also, to be more practical, recently has been published also an update specific for lunar surface exploration scenario based on 3 phases. Let's say first boots on the moon, then expansion and building, and then sustained opportunities in there. So coming to AI, if we consider these 3 big steps, I mean, robotics missions come first. What AI can do for that? Reason in terms of macro areas. Autonomy, definitely, because you can enable onboard reasoning, analysis of images, and flexibility, but mainly the knowledge approach of AI will allow you to move from a task-oriented scenario into a goal-oriented scenario, so you don't program what is asked to do specifically, but you provide the system with a goal. Then you move into the second steps where you start working with robots and humans together. And here the role of the AI will be not only autonomy, but also human-computer interaction, because the goal here somehow is to be able to make 1+1 man and machine, not to make 2, but make 3, 4. So you get into the realm of new technologies that you will need over there, augmented reality, that we will talk about this. Then the third steps, colonization. Okay, colonization, why is that different with the previous scenario? Because this will entail or will foresee a merging somehow between the humans and the machines, and that will be living in an AI-based ecosystem. Why we need that? Because if we need to go to colonization, we cannot rely on superhumans like today's astronauts. You will have to bring there for longer time and other type of professional. Just to be clear, I'm not talking here about space tourism. But this is fancy and interesting, but I'm talking about bringing specialists, but not astronauts like geologists, engineers, for instance, that you cannot expect them to be so good as today's astronauts only in managing the environment. So you need a step ahead, let's say. So when we come with robotics with time delay, we can devise different levels of control, going from haptic telepresence, telemanipulation, supervisory control, up to autonomous decision making. So here, and when you have to interact with this machine for carrying different type of tasks like relocation task, construction task, manufacturing, in situ resource utilization, on-surface seed preparation and maintenance, then you will have to get into the realm of new technologies besides those that support autonomy, like natural language processing, for instance, augmented reality that, as I said, for entailing and devising new way of controlling the robotics and interacting with them, as well as multi-agent, for instance. This is going to be a system of interaction of human and machine. And there are studies in this direction in AI to be able to manage the knowledge about the interaction around these systems, because you don't expect this machine, to be simply operated like a lunar rover, but we expect more. There is the concept of augmentation. So you will have, the machine will have to contribute in augmenting the human being capabilities. Then when we come to colonization, we get to ambient intelligence, as I said, the base ecosystem to support crew autonomy beyond the LEO and mission control automation. Here you will have a concept like intent recognition, intelligent assistance. The environment has to be designed for reasoning upon what's going on from the sensor. This is more than simple. It's not simple, but it's more than conceptually situational awareness, because the environment has to be able to think and to manage information about everything that's going around, because the single event might assume a different meaning depending on the surrounding conditions. And this can support very important things like crew health and performance, crew safety, design of robotic caretakers, food production. This is another big topic. So this is the future, well, up to a given point, because this is already there. There is an AI report that shows that more than 120 activities going, that surveyed more than 120 activities already going in ESA, in connected AI, in 60 areas of application, subdivided into 4 domains: development, data exploitation, corporate, and operations. And it's serving a targeted type of application in the field of perception and learning, machine learning, prediction forecasting, natural language processing, image analysis and classification, in the field of knowledge representation and reasoning, planning, scheduling, resource optimization, knowledge engineering, and as well as in the field of action and interaction, because this is the more you move towards the merging between human and machine, the more this becomes important. A methodological way of doing that is also analyzing the strengths, weakness, opportunities, and threats that AI can pose, can pose to us, and thinking how we can put AI into the loop, but also what it can do for us, but also which risks we will have in doing. We cannot go, all the different, over all the different applications. For instance, in design, we have application for engineering knowledge and capture, concurrent design facilities, AI for complex systems, AI for onboard autonomies, as we said, payloads and for control and fault detection and recovery, all the field of robotics, reliability management, and so on. When it comes to operation, and the aims of is introducing technology to automate the operation, but also to change the operational concept, because the more that we move and we introduce AI at design level, the more we will need different operational concept to manage it. So here where it gets into the loop concept like data analytics, predictive maintenance, memory management, dependencies analysis, as well as, for instance, AI for space safety and condition risk estimation. Regarding AI for data exploitation, this is most probably the most known area at the moment. We are doing a lot of fancy things with the data using AI, extracting information, as I said, reasoning about knowledge about the data, not only about the data itself, like, for instance, classifying images on board and decide which one we want actually to use and upload, even from the past, because the EU1 mission from NASA, for instance, has been running AI on board for almost 10 years now, but not only scientific data, also navigation, science data, telecommunication data, observation data, and as well at the corporate level, for instance, the management of the knowledge, because we work with missions and specific projects that can last years and years. This is a specific feature of our project. So you need somehow, I mean, you're going to operate missions that have been designed by people that are not really even anymore working. So you need to somehow a way for structuring, managing, and transmitting this knowledge. This is a panoramic view of what the AI can do for us in the macro areas of autonomy, human-computer interaction, and ambient intelligence. But there are also some risks, because look, I mean, this is on the left, we have this Simon intelligent assistant that designed with the collaboration of DLR, for instance, interacting with astronauts. On the right side, we have the well-known space odyssey issues, where the AI try to take the control over the human being. Is that really that far? Actually, is not. This is the knowledge loop that I've been mentioning before is the one that is actually entailing this risk. This is not the most science fiction part of the movie, let's say. We can play the video at this point. So what we are going to see here, first, an interesting application. I mean, this is the state of the art of Boston Dynamics regarding robotics. I don't know if you feel comfortable or uncomfortable about that, but sometimes I feel a little bit uncomfortable looking at that. This is somehow amazing. This is pure reinforcement learning, by the way. This is what you can do. But this is somehow still in vitro AI. Here we have the very same robot at the end of a public demonstration.
One other robot, the latest one.
Oh, get wrecked. Oh, I can't believe it. The dude just got wrecked.
Here we have another example of a robot interacting with a door. Here you can see the neural networks that are working and extracting knowledge. Okay, so understand this is a door. Okay, he sees the door, then he has a knowledge base, and he says, okay, I mean, the door can be open and needs to be opened. So there is an handle, I need to interact with the handle. Everything goes fine until to the moment that there is a failure, because the robot is actually missing the handle and is falling down because he's not able to balance his forces. This is why, because the information has not been managed at the right knowledgeable level, and there was not interaction between what it was managing at the level of pressure on the handle and what it was. Okay, so we are back, and we we go towards the conclusion. So do we have to worry? Yes or not? Yes or not? Why? Because there are definitely challenges in applying AI for space exploration. Apart a technological issue related with the computational power that we need, AI needs a lot of computation. At the moment, we are working on it. Maybe in the future, quantum computing, if we ever go anywhere, it will solve this issue. But we will need many computational power for these fancy things. But then there are different challenges more related to the nature of the AI approach for space exploration. First one is related with the need, with this approach of learning from data. The question is how far we can go with that. There is this joke, for instance, where robots taps at the war and they're attacking humans using swords and archery. Why? Because if you look at the data of the past, most of the wars have been fought using this medium. Thanks to God, we almost never use a nuclear bomb, but this doesn't mean that the nuclear bomb is not the right way for fighting a war. So this poses an issue of what actually these machines are actually learning or are working with. Another issue is related with the general understanding what they are doing. You look at the joke on the left, for instance. Over there, you need first to understand that a sort of anomaly detection. There is something different that comes from what you read and what you see. So this is already a cognitive step, not easy to carry on. Then you analyze the picture and you realize that something is strange also at the visual level, another anomaly that you detect. And then you need knowledge that comes from a completely different field. Maybe you studied, this strange hat this guy has, and you can identify him as an ancient Roman. So you may know that ancient Romans were using different numbering system. And then finally, you can get to the point of what you are seeing. This is out of the possibilities of any AI at the moment. So the question that is raised is, what do we do? Because there is an actual issue in verification and validation of this system. So you cannot, this is a theoretical result that was very well known in the 50s. It disappeared when the AI was only on papers. Then we start to produce applications that were very simple and the issue somehow disappeared. But now we put it under the carpet, but now it's coming back because you cannot really validate and verify these systems in the traditional way that we are used in the space industry. And this is a big issue. So what do you do? We are left with no hope. We just cross the finger. We put these machines beside astronauts on a moon base, and we hope that everything goes in the right direction. No, we are studying sub-solution, and it stems, for instance, in the hybrid AI and trustworthy AI. Hybrid AI aims at hybridizing the approach, mixing models and learning, for instance. This is something that has been already understood in science fiction by Isaac Asimov. I don't know if you remember, if you were passionate with these books, where there were these machines with this positronic brain, but then there was a model on top, three laws of robotics that they were there to avoid this problem, because the key point of the AI is that you don't know at each moment which is going to be or what is going to drive the transformation of data into data. You can argue that this will not solve the problem, this will not solve all the problems, but it's something that you can think about. And then this brings us to the concept of trustworthy artificial intelligence. That is a very important topic. Explanation, that's the key word. If you cannot really verify a system, you can make it explainable. So during the interaction, you need to be able to understand what is the actual, let's call it, status of the knowledge of the system for being able to trustworthy use it in space exploration. This brings us to the conclusion. One last point that I wish to make. We have seen what AI can do for us. We have seen opportunities and risks. We analyzed some possible solutions to cope with the risks. But what can we do for AI? AI does not come by itself. So first of all, there is a need of an awareness of the AI potential. Understand the approach of AI and being able to instantiate this approach into our specific field of work in space. Then we need to consider the AI. We start to consider the AI since the early mission design phases, not only as a patch afterwards. It would be interesting to involve AI experts when we design missions. Third point is data. We need data. I mean, AI needs data. Data that should be made available and at the right semantic level for being usable in AI. Last but not least, coordinate design, operation, and exploitation. Because the entire introduction of an AI approach, as we have seen, goes from the design, the way that you interact with the system, as well as the product and the use of the products that the entire loop is going to produce at the level of information and not at the level of data. I wish to conclude with the need of creating a community AI, around AI, because the ultimate goal probably of the space exploration, I don't know what we have in mind, but I don't think that we are thinking to do all of this to go on the moon or Mars and to start to dig. We will probably need something more, and definitely AI can be can support this view and this vision in this direction. This concludes my presentation.